Hey, welcome back to another example on using the integration by table method for solving integrals in a calculus 2 kind of environment. So in this problem, we have the integral of sine of x over cos squared of x dx. And the goal is to figure out what is the solution to this integral, or figure out what is I. Now, when I first look at this, I have absolutely no idea. And I see like multiple coses in a denominator, and that starts freaking me out, and I'm not sure if I'm going to have to do this by parts or by substitution or something. But this one we can do purely by the table method, and the table method, all that is using our integral table, which is right here, and I'll put a link to this in the description below. This is a very typical integral table that you can access and even print off the PDF version if you want, but basically there's a whole bunch of different integrals in here, and we're just going to try to rearrange to get it in the form of one of these, and we might even have to use some of these trig identities. So you see fractions that involve trig functions, or especially trig functions in denominators, or trig functions squared. Try splitting them up, like this is a cos squared, so write it as two different cos functions if you have to. And consider that when you see a cos or a sine in a denominator, that this might have something to do with like cotan, cosecant, or secant functions. So let's rewrite this, just like split it up a little bit to make it easier for us to kind of see what's going on. So we have sine of x over cos of x times cos of x. Right? That's just cos squared x, and that was all dx. We can rewrite this again if we wanted to. So this is the same thing as the integral of 1 over cos of x times sine of x over cos of x. Right? We're just rearranging very simply the exact same stuff up here, but now we can kind of split it out and get a little bit better of an idea here. Now, when we look at 1 over cos and sine over cos, and then we look at our trigonometric identities, which are in the bottom part of the table here, we see 1 over cos is equal to secant, and sine over cos is equal to tan. So let's bring that over. Now, the table was showing in terms of theta. Here it's in terms of x. It doesn't really matter. It's just like a label that we use, a variable to describe the angle. But basically, we can write this as the integral of secant x being 1 over cos times tan of x, which is sine over cos of x dx. Now when we look at this, the integral of secant x tan x dx, let's take a look in our table to see if this form shows up. And when we look for it in here, sure enough it does. The integral of secant x tan x dx, this is a pretty common, well-known integral, and it's in the table for that reason. And so the integral of secant x tan x dx is just equal to secant x plus c. So let's just write that on our worksheet, maybe up here in a different color. So from the table value, we had secant x tan x dx. This is equal to secant x plus the arbitrary constant c. Notice that we don't have an integral sign here anymore because this is the actual solution, and we're just substituting this whole integral for the solution. So we can just write that simply, that I is equal to secant x plus c. And that is the solution that you would be looking for when someone asks you to solve this integral.